Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Component Review, or Components Review. We're looking at the logic board for an EBMX X-9000 controller. People like to think of me as a fanboy or something like that. How about I just like good design? That's all there is to it. And well, EBMX has got it in spades. That's about all I can say about that. A lot of attention to detail, lots of handling a lot of things that lots of other people don't even think about doing. So yeah, good job EBMX. You guys do a really good job. So yeah, if it sounds like I'm a fanboy, you're wrong. I just like good design work. Anyway, this right here is the main DC to DC circuit for basically taking battery voltage down to 12 volts. Actually, it's 13 or 14.8 volts, or 14.3 volts rather, to bring things down to more palatable level for everything else. Anyway, this little chip right here, that is a U3018, and that is from a company called Uni-SE, and it can handle 15 to 180 volts in and produces 14.3 volts out. So this little bit of circuitry right here is about that, and you've got a couple filter capacitors, and you got a ceramic cap on there, and there's the inductor for it. Okay, so this is one of those cool things, and it is duplicated on the board. So this is one of those, great little attentions to detail that EBMX has done. So right here, this little bit of circuitry, that's a second DC to DC converter, and this little chip right here, this GAFAB. I don't know what it is. I couldn't find the part number, so I can only tell you what it is because it's obvious. But anyway, yeah, this is a little 5-volt DC to DC converter, so it's taking the 14.3 volts from the other one and dropping that down to 5 volts. So, and that's its whole job in life. Anyway, yeah, I don't know what this chip is. I wasn't able to find it. I Googled for it in several different ways, and I couldn't find GAFAB, so maybe somebody else can tell me what that is. But yeah, this is just a little DC to DC converter for producing 5 volts for all the onboard electronics. All right, right here, this is a TMS 1117, and that is a 3.3 volt linear regulator. ASI uses it, obviously EBMX does. It's on the KO controllers. I've seen it on several other ones. Yeah, originally I said, no, I don't really like linear regulators, and I would have to say I still don't, but a lot of people are using them, so, okay, whatever. I would much prefer that everything be DC to DCs, like, say, the Trampa controllers are. But, it's a viable solution. It obviously works. Okay, right here, this little bit of circuitry. That is one of the gate drivers, and that guy is a commonly used chip that I've run into many times before, and that's an EG2181. Basically, MOS transistor, IGBT transistor gate driver chip. Yeah, I've run into this exact same chip, this 2141, several times, or sorry, 2181, several times on different controllers. It's a very commonly used part. No big deal there. Let's move on a little bit. Okay, so right here is one of your current sensing rings. So this is a lamination stack of thin sheets of steel, basically, and that's its little linear sensor in there. So when a phase is on and conducting current, this picks up a reflective magnetic field on it, which it then transfers over to that little linear Hall sensor right there, which is just a magnetic detector. And its output signal is used to tell the CPU that XYZ amount of phase amps is present. That's pretty much all that's there to that. Okay, so here's your CPU. This little guy right here, this is a little clock component. It's got a little piezo crystal inside it, and when you apply volts to the thing, it vibrates at a very fixed frequency. And well, the CPU needs this, and you'll find a clock, a little crystal oscillator like that inside everything. They're exceedingly common because everything needs to have a very, very consistent and controlled timing signal. All right, so the CPU itself, this is a Giga device, GD32F405. It is a close relative to the ST Micro part, the STM32F405. Slightly different. It does use some different libraries, and the fact that EBMX was not able to get their live STM32F405, they had to use this guy. And in the process, since that was the situation at hand, they had to do new VESC development. And so now VESC can run on another chip that it never has run on before. So, good job EBMX for doing that. No one else would have done it, I don't think. They would have probably just simply not made controllers instead. But there's nothing wrong with the part. It's a perfectly functional chip. It's running the full VESC FOC suite. So, yeah, I can't really say that's bad. It's just not the ST Micro part. It's, another solution. So, good for you for coming up with another solution. When there's a chip shortage, you got to do what you got to do if you're going to build controllers. So this is that other onboard 5-volt circuit. Taking creating its own dedicated 5-volt source for all the output stuff. Like throttles and LCD and Hall signals for the motor, all that kind of stuff. Its own dedicated 5-volt regulated supply for all that stuff. So that's super cool. It's another one's attention to details that nobody else does. Yeah, I have yet to see another controller with a dedicated 5-volt power supply just for external stuff. It's unheard of. I just never run across it. All right, so down here in the I/O connectors, another attention to detail. I'm going to harp on that one quite a bit because EBMX has it in spades. Man, they have done it on all kinds of stuff. Good for you guys. I like good engineering, and you guys have done a lot of good engineering. So all these little components right here, this is part of protection electronics, and you have throttle signals, brake signals. I don't know what all is in here, but yeah, all these little components right here, this is all protection electronics, so that if something goes bad on the outside, it doesn't backfeed into the controller and blow up stuff on board. Instead, it's protected by all this stuff, which these are... I forgot what the exact part is, but they're basically a resettable fuse. They only allow load to happen for a while, then they open on their own, and then they will close again. These might be TVS. That's what they are. But yeah, they're a special kind of component that will protect the electronics behind it from getting fried by external stuff. And that's really good. This is another thing that I just don't see anybody else doing. But it's a really good thing to have, and I can tell you for a fact, because I've done it, I've blown inputs on controllers before, so that they're no longer usable. The controllers still work, but that input was now gone. Well, with all this protection stuff on here, there's a pretty good chance that's not going to happen. All right. So you can see these 4 little guys right here, and those are P-channel MOSFETs, and they are switching stuff. So let me get to that right there. Not you. There it is. So those are YJQ50P03A P-channel MOSFETs. Their job in life is to turn stuff on and off. So probably like one of them is for turning like off the water pump. Another one's like for your headlight or something like that. I honestly don't know what each one of them does or what the options are you can set for them. But yeah, these are there so that you can have a connector coming out of this thing that will turn other stuff on and off from within control that you have on the the motor controller. Yeah, EBMX has thought of stuff that nobody else does. Everybody else, if you want things like this, you add it externally, and they've added it here. These 4 little guys right there, those are also MOSFETs. They are adding a second layer of protection behind these MOSFETs. So if anything goes wrong on the outside, things backfeed as far as here, and they probably won't get past these little MOSFETs to damage anything else. So that's kind of what those are for. Yeah, another level of protection. Can't fault that even slightly. All right. So right here is the 3rd gate driver. So I'm not even going to bother talking about that. And here's the center gate driver. And, all right, there we go. So this is an opto-isolator. On this side right here, there's a diode, and on this side over here, there is a transistor. And in between the two is a gap. So electrical signals from here can't get to here because it would have to jump that gap. Electrical signals from here can't get to here because it would have to jump that gap. The only thing that passes through that gap is photons. So you turn on the LED, and that turns on the transistor. Turn off the LED, and the transistor turns off. And it's all done with light. So it creates electrical isolation, and this is here for the 12 volt 5 amp DC to DC converter that you use for external peripherals. So yeah, that's a super cool thing that they put that in there. That's called protection. That's called attention to detail. And again, EBMX, you got it in here. How cool is that? So this is the that's the buck chip for that 5 amp 12 volt DC to DC converter, and that is a Texas Instruments part, and that is a TL3842, I think, and they call it a performance current mode PWM controller, aka a buck. A buck control chip. You know, take battery voltage and drop it down to 12 volts. That's what its job is. This large capacitor, that Aishi, yeah, that's the DC output side filtering. You know, you can see the inductor right here, and then over here in the corner, this capacitor. It's part of all the rest of them, but it's where it's located. It's pretty much dedicated to filtering the power bus. You know, the main battery bus, just for this little DC to DC. But that's what that one's for. And you've got some resistors and things in here that are also part of the circuit, and a tantalum cap for dealing with high frequency noise. So all this stuff is pretty cool. And now I need to bring over the power stage for a second. All right. So I was mistaken about these two components. I said they were both MOSFETs, and they aren't. This one is a MOSFET, and I claim that that one like turned on and off the fan or the water pump or whatever, and that's not the case. That's those other ones. And this is actually a Schottky diode. And let me grab that data sheet. And that is, there it is, that's an SF1001 super fast recovery rectifier. I knew this was here, and I was just not thinking about it the other day. But whenever you have a switching power supply, aka a buck converter, you are taking some voltage at DC and you're turning it into an AC signal at high frequency, and then you're converting that to some other voltage that's also AC high frequency, and then you rectify it back to DC again. This is a very efficient way to convert voltage from one thing to another, which is why it is I like DC to DCs so much anyway, rather than linear regulators, because they're so damn efficient. Well, anyway, yeah, this little diode, it's the rectifier, and it has to be a high frequency one, aka a Schottky diode, or as they call it, a super fast recovery rectifier. Yeah, aka a Schottky diode. So yeah, that's what that's doing. It's just doing the rectification from the high frequency AC back to DC again. And this right here is the actual MOSFET, and that part is a CR Micro CRS D082N10L2. And it's a little 100 volt MOSFET, and that's the this part right here, and all of that stuff right there makes up that 12 volt DC to DC converter, you know, at 5 amps that you can use for powering external stuff. So anyway, once again, a lot of attention to detail in here. Lots of decent components and good layout and protection electronics and all that kind of thing. I can't fault anything here. This is all, you know, well thought out. Yeah, when I see stuff like this, where all the I/O pins are protected, all I can say is, good job, EBMX. Nobody does this. You know, a dedicated DC to DC for all the external stuff. Good job, EBMX. Nobody does this. Opto isolation for your onboard 12 volt DC to DC converter. Good job, EBMX. Nobody does that. So yeah, I mean, once again, you know, the more I look, the more I find things I like. Can't fault this at all. This is all very good. So yeah, good job, EBMX. I might sound like a fanboy, but yeah, it's because I am. You guys do good design work.